Hello, everyone. Welcome to asset tracking, to our January Impact Spotlights. This month, we are focusing on asset tracking. I'm Jesslyn. I get to help out with Impact Spotlights in this live stream today. Asset tracking as a theme is all about not only tracking what we buy online, but things that are important to us, like pets or packages, or people. So let's just go ahead and get started. Our very first community spotlight that we get to share today is by Arduino Celentano. It's Silly Space Invaders Dashboard, a wireless AP monitor with some really cool technology.
Hello everyone. First of all, thank you to the Hackster.io team for inviting me to present my little project. It is called the SSID, which means Silly Space Invaders Dashboard, and let's look at it. The idea was to make a funny IoT device that helps you to monitor the wireless activity around you. It represents the Wi-Fi access points with animated sprites that resemble the characters from classical arcade games. You can see they are arranged in 5 rows, and the signal indicator is to the right, so it shows that the characters at the bottom row represent access points with the strongest signal, and the creatures at the upper row represent access points with the weakest signal. And finally, at the upper part of the dashboard, you can see the labels with access points names. This little device could help you to see what happens in the wireless space, what access points appear. Maybe it could detect some basic wireless attacks like access point cloning. You could see several access points with the same name, maybe beacon spamming. So that is the reason I find it funny to call it space invaders, because it helps you to probably to detect some invaders in your wireless space. As for the hardware, it's pretty much accessible, it's pretty much affordable. If you are watching this video, you probably already have it. It's ESP8266 microcontroller from Espressive, and pretty much common I2C OLED display. I prefer two-color display, yellow and blue. It helps to distinguish two areas of the dashboard. In fact, I used an integrated solution, a board with Espressive microcontroller and the display. There are a lot of them. They could be used in this project. You just should to check out the wiring, the way how your display is connected to the microcontroller, and maybe implement some small fixes in my code to make it work with your particular board. As for the sprite design, I found out that apparently we cannot use original sprites because they are protected with some sort of copyright. So to make it open source, I designed my own sprites. You could freely use it if you wish in your other open source project. There are 3 characters for protected Wi-Fi points, and the spaceship represents a free Wi-Fi access point. Additionally, you'll see a laser cannon below it, so you could easily distinguish free Wi-Fi access point on the monitor. The algorithm is pretty much straightforward. First, we need to scan wireless networks, then we sort it into 5 clusters, so that each cluster represent a row in the dashboard. They are sorted by the strength of the signal or RSSI value. For each access point, we create an instance of invader class, and they update OLED function as is obviously update the display and renders the picture, and this loop is repeated every few seconds, so the dashboard is updated. What could be done with it in the future? You could integrate it into a wearable device or maybe a desktop gadget to see the wireless activity around you. There are already there are different dev boards in some in this form factor, so you could use readily made one, or you could design your own if you wish. If you like the project, you could follow it on the Hackster.io page. The source code is available on the GitHub page. And thank you for your attention. And now let me show you the dashboard in action.
Yeah, that is so cool. I love that, the demo at the end, how cool it makes. It's really cool, and it's, a really cool visual representation, and a nice throwback, just to some nostalgic technology and video games. So I'm excited again to, introduce our next presenter, Sokola Robot, who's developed a smart laboratory asset management system. Um, so again, keeping track of people, places, and things with all of our asset tracking.
Hello everyone, thank you for Hackster for invite me on the Impact Spotlight. Today I will share about my project, a Smart Laboratory Asset Management System. Okay, my name is Dadang. I'm the founder of Sekolah Robot Indonesia. Sekolah Robot Indonesia is a non-formal education that introduces about robotics and helps students to learn about building and programming robots. In addition, I am the ASEAN Regional Coordinator in Marine Advanced Technology Education, ROV. Also, I have been an initiator of Makerfire Surabaya. At Sekolah Robot Indonesia, we have implemented basic inventory recording using a local host server, allowing us to track and maintenance laboratory assets such as toolkits, electronics component. The system provides a centralized database to store key information like location, status, and maintenance history. But our system does not have real-time tracking. For standard basic inventory system is built using PHP, MySQL, HTML, CSS, and JavaScript. Okay, to address this, we aim to enhance the current system, integrating IoT and artificial intelligence. This will allow us to automatically providing any update and leverage predictive analytics for maintenance. So this is a bill of material use. In this project, I use product from DevRobot. Thanks for Hackster and DevRobot for giving me Hackster AI toolkit, and I combine with my Husky lens from DevRobot 2, which is an amazing camera for learning AI. And I prepare my backboard for the sampling project. For hardware, I only use FireBattle ESP32, IO Shield, and I want to make a sound MP3 notification, so I use the F-Player Pro completed with the speaker. And also Husky Learn to learn my toolkit in the backboard. For wiring, Husky Learn connect the ESP32 with I2C communication, and the F-Player Pro connect ESP32 with serial communication. For all programming, I use Arduino Cloud, so it is easy to use, and Arduino Cloud completed with any board you use, and already all library if you need. In first prototype, I use only for tag two detection tool in our laboratory backboard. So first I must learn Husky lens in multiple tag recognition. This is old table in database system or basic inventory, and for integrating with this project, we must add one table again to support IoT system. And this is a front-end design for easily detection where tool use. I use image as display in website. So if image light off, is mean the tools is go away from my backboard. Okay, and this video my project. data barcode tag after learning from Haskell will be processed by ASP32 and processed to the database local. So like this. This front-end website will be show like this. It's amazing color. If we take this tool, and in front end is the image is show off like this. So if we take again in backboard, the image will be show again. Finally, I make a simple cover from a plastic box, and for the F-Player Pro is function to give sound if my laboratory is completed or not. So like this video.
Congratulations, your laboratory is completed. Your laboratory is not completed. Please check again. Congratulations, your laboratory is completed.
In the next step, I have running project to industrial warehouse, and I want to optimizing warehouse operation with ultra wideband based inventory management, so I can track where last location my inventory. Thank you for everyone. I hope you enjoy my share project, and I hope we can collaborate about warehouse inventory management. Thank you.
Wow, that was really cool, especially seeing the Hackster EDU kit in action for such an awesome and useful project. So next up, we have another project from a community member, this time Alex Lind. And this is their DNS driveby, which is stealthy GPS tracking using open Wi-Fi. And I'm super excited for all of you to see this one.
Hey everyone, I'm Alex Lind, and today we're taking a look at a project I made called DNS Driveby. So DNS Driveby, it's a stealthy GPS tracker which takes advantage of a flaw in open Wi-Fi networks. I made this about 2 years ago. You can check out my Hackster write-up. You can also see the 2 videos that I made on the Hack5 channel and my personal channel if you want a more thorough rundown. But for a brief introduction about myself, I'm Alex Lind. I am a cybersecurity content creator. I'm a hardware hacker and a product developer. So I spend a lot of my time working with signals intelligence and Wi-Fi reconnaissance. I do trainings and YouTube videos, and I also make a cat-themed product. You can check that out at devkitty.io. I use it to teach beginners about hacking. Nowadays, I'm trying to get more involved in the education space. I found that early on when I was learning a lot of these things, it wasn't exactly accessible or viable, and a lot of it was intimidating, and my hope is to kind of open up that world to other people, which is why I create projects like this to showcase interesting vulnerabilities and try to keep the BOM cost as low as possible for people that might want to replicate one of my projects. So let's dive right in. The initial concept for this, I was doing a tracking challenge with a couple friends. You can check that video out. And I saw a statistic from Kaspersky. I think it said 1 in 4 or 1 in 5 Wi-Fi networks is completely open. I thought that was crazy. That means if you're in a dense enough urban area, 25% of the times you would be able to hit an open Wi-Fi network from a coffee shop or hotel or whatever. Be able to send telemetry across the internet, like GPS data. So if you don't need a persistent connection, like from a typical LTE SIM card-based tracker that you can buy on Amazon, that means with a $3 Wi-Fi chip, like the ESP8266, not only is this non-attributable if it's discovered, but you'd be able to just fire off data intermittently every time you hit an open Wi-Fi network. So this was the original concept photo that I created when I ideated this. I was like, how can I crowdsource war driving? can I strap a tracker on a cat or a public bus and just have it drive around for me and upload data every time it hits an open Wi-Fi network? And this did end up proving successful. And if you're not familiar with war driving, by the way, war driving is basically just mapping wireless devices. With a couple minutes, you can drive around your whole neighborhood block, right? If you have a device that has both Wi-Fi or maybe another wireless protocol, Bluetooth, cellular, and GPS, what you can do is you can actually geolocate all the devices that you see along your path. So this is a really useful thing to have in your hacker toolkit. If you want to go back and determine like all the vulnerable routers in your neighborhood or how many people have a certain type of device, performing a survey like this is relatively easy through war driving. So that's initially what my thought was, like, how can I crowdsource this without subscribing to a SIM card fee? So for a total build cost of around $7 at the end of it, I used a $3 chip. I used a ubiquitous GPS module, the Neo 6M. You can find that for about like $4 or less on AliExpress. A LiPo battery, and also some 3D printed components. My favorite part of the build, though, was creating the low power hardware. So for the tracking challenge, we were tracking my friend as he drove throughout LA, but I needed a way for it to conserve battery while his car was turned off. So what I did was I hooked up a vibration switch to a couple transistors. I hooked this up to the power pin on the ESP8266. So by default, it was hibernating, but whenever motion was detected, it would just send current through the power pin, wake the device up, and then it would, at that point, start scanning for Wi-Fi networks, GPS, performing its full cycle of looking for open Wi-Fi networks and firing that data across the internet. I also ended up creating a custom memory buffering solution. If you want to check out how that works, again, go look at the write-up. And one of the caveats with this, though, it's not as simple as just connecting to the network. If you've connected to an open or free Wi-Fi network, you'll know that you've probably seen a captive portal like this before. So to completely circumvent that, turns out you can just use DNS, the domain name service. So this is a technique that is actively being used by adversaries to exfiltrate data out of sensitive networks. Instead of sending data the way you typically would across the internet through like HTTPs, like through a post request, for instance, DNS is used to resolve domain names. Like if you were to type in Google in your browser, say you're just connected to Starbucks, you haven't logged into the captive portal page yet. What DNS does is it reaches out to a domain name server. It says, what is the IP address of google.com? And then it attempts to resolve that back to your computer, because your computer deals with IP addresses, not the actual string name. Server side, Google is able to see that you hit their server, even if it wasn't able to resolve on your end. So what this means is you can just go ahead and append arbitrary domains like docs.google.com, sheets, slides, etc., and fire that off. As far as I'm concerned, from a telemetry perspective, what this means is I can fire off one-way requests for whatever data that I want to encode in that URL, right? Provided that I'm hitting a domain name that I own. So I did exactly that. I had the device compile a database of all the GPS locations that it was logging. Since GPS has commas and periods, I encoded that to base 32. But then I appended that to a subdomain that I owned, which was alexlin.com. So every time it hit an open Wi-Fi network, it would create a DNS request saying, what is the IP address of gpsdata.alexlin.com? I don't need to actually resolve that. I don't care about the IP address. But the fact that that went through to the other end, on my server, I'm able to pull all that data. And you can see that in the end, we were able to gather a couple hundred different data points throughout my friend's route as he drove through LA. Again, this is provided that you're driving through a dense enough urban area and you spend enough time close enough to open Wi-Fi networks. Pulling the statistics in the end, too, we were able to show that around like 20 to 25% of the networks that he passed by were, in fact, open Wi-Fi networks. I thought that was pretty crazy. If you're curious about the service that I used for this, check out canarytokens.com. It's a really awesome solution for creating free honeypots. In my case, I used their DNS token, where you can use this to try out DNS exfiltration. But they provide a free web interface. I was able to use this as kind of a rudimentary database in a way to just easily decode that text that was coming in and log those GPS points. So if you're interested in seeing more projects like this, go ahead and check out my website, lindlabs.io. But yeah, to wrap things up, this is a viable tracking method, although a little bit cumbersome. But the main thing that I was hoping to spotlight here is the vulnerability that exists in open Wi-Fi networks. And I wanted to highlight DNS exfiltration as a way of accomplishing that, because this is being used. And for a build cost of just $7, you can only imagine what an adversary who has access to more expensive tools would be able to accomplish. If you're wondering about ways that you can patch something like this, from what I recall, there's a couple different methods of standing up a captive portal. One of them is DNS based. So instead of just doing a simple redirect, when you type something in a browser to the captive portal page, you can actually just block all DNS queries, and that would be the recommended way to patch a vulnerability like this. So if you're interested in learning more about this, check out the write-up, check out the YouTube video, and I appreciate your time. Thank you for watching.
That was I saw in the comments some people are excited to start tracking their cats, and yeah, Alex Lind has some really cool technology that they've shared before with us and done some workshops. So that's a very cool and realistic use of that technology. And last but not least, for our asset tracking community spotlights today, we have from Manivanan cold chain monitoring, which is using the Nordic Thingy 91. I'm super excited for everyone to learn more about this project, and we also love Nordic and the Thingy 91. So enjoy.
Hello everyone, my name is Manivan Sivan. Today I'm going to present about one of my project cold chain monitoring using Nordic thinking. So I'll share my screen to get started on that. My screen is visible. Yes. Yes. So today, the topic I'm going to present is the cold chain monitoring using Nordic Thinking 91. And regarding myself, I'm Manivan Sivan. My passion is to work on the embedded machine learning projects. So usually in my free time, I used to create some prototypes and consider some real world problems, how we can solve using the edge AI techniques. So I usually buy some different boards and export different sensors and try to just do some creative approach for solving some issue or the real world problems. And I publish all my projects in the YouTube and also in the Hackster. So you can see all my projects in the Hackster website as well. And regarding my career, I'm working as a charging control software engineer in Jaguar Land Rover, UK. Yeah, that's all about me. So today, the prototype I'm going to explain in detail is about the cold chain monitoring and what that it's going to solve in the real-time issues like this TinyML model is going to monitor any cold storage of the entire container or any compact boxes or anything. So we can fit this, we can just flash into the Nordic 91 and then fit into that device or the container, and then it will monitor the all the environmental data and then predict whether is in the normal conditions or is there any direct sunlight exposures or is there any overheated condition or is like it's spoiled down. So this Nordic 91 has a n number of sensors. So for my project, I specifically need to know about the infrared because to understand whether there is a direct sunlight is falling on that container or not, and the accelerometer XYZ to know there is any the object is just fall down or is there any sudden shock so that it is affecting the objects inside the container, and the temperature and the yes, so majorly I was focusing on that. And yeah, so for my prototype, I need just a Nordic Thinking 91, which is inbuilt with all the sensors, and the software I have used is the Edge Impulse, which we can directly download the firmware from the Edge Impulse to the Nordic 91, and then you can just directly do the data acquisition from the Edge Impulse website, and then train your model and verify the model in Edge Impulse, and then you can just flash the X file back to the Nordic 91, Nordic Thinking 91. So the challenges. So in the cold storage, what are the major challenges which we are facing in the real time is like heat exposure. So some of the objects which is they are transporting from one place to another place. So some objects are sensitive to sunlight exposures, and some are sensitive to heat exposures, or some will be like a more fragile, like it should not damage due to sudden shock or falling down. And also the humidity matters, like it will enhance the growth of the mold. So these are the major challenges in the current cold storage. So how my approach will reduce the um, wastages, and it enhances the real-time monitoring without a much cloud dependency. Let's say that's what AJ is. So we don't want to have a cloud everything. Like the entire algorithm will be in the microcontroller. It will detect that incident in the real time, and it predict what kind of result it is, and then the result alone it can be communicated to the user or the any platforms. So that it's not like larger amount of processing is not going to happen in the cloud. So the all the detection is going to happen in the same microcontroller. And so this overall, you can see there is, I'm using for the prototype, I've used a normal vaccine box, and I've just fitted the Nordic 91 on top of that. And you can see that there is a block dot which just absorb the, so it just read all the infrared. And yes, so the data acquisition, as I mentioned, it will be in the Edge Impulse. And the pre-processing, I've used three pre-processing blocks. Like one is the flatten, and another one is the spectral features, and another one is raw. So the raw is used for the temperature, especially. Spectral features is mostly commonly used for the accelerometer X, Y, and Z, and the flatten I used for whole. So once output of all the pre-processing, and then I've used the neural network classifications. So later I'll explain in detail about that. And the outcome of the neural network classification is that whether it's any sudden shock or the sunlight exposure, it's a normal or is it overheated. So these are the techniques. I mean, these are the outputs. It comes as an output from this model. So the data acquisition. So for normal condition, I just kept an ice pack inside that and just observed in a very lower temperature and recorded all the data. And for the sunlight, I just kept that entire vaccine box house into the direct sunlight exposure and sudden shock. So the cold chain, some of the objects might be very sensitive for vibrations. So I used to train my model by applying a sudden fall or up vibration, so that you can see there will be a drastic spikes in the X, Y, Z accelerations, and those data is captured and labeled as a sudden shock and overheated. So usually I just change the temperatures, and I remove the ice pack and just maintain a very hot condition, and then I recorded it. In order to go a little deeper, maybe we need to see how the I've captured that the real-time data. So I've just explained all this in the one of our Hackster project. So I'm just like to show you that setup. So you can see this is like a direct sunlight exposure. So I just kept and recorded all the data. So in the real time, how that it behaves. And then want to go to the yes. So this is the complete setup, like for training my model for this project. So you can see that window says I just kept as a 500 milliseconds. So 5 seconds of data, and the window is the stride is 3 seconds. And the select, this indicates like what are the blocks I'm going to use, the pre-processing, and what are the inputs for that blocks. So for the flatten, I have used the XYZ temperature, humidity, and the infrared. For the spectral, I've used all the accelerations, and the raw data I've used the temperature. So these output will be used set as an input to the classification, the Kera. So here the normal neural network classifier. So these are the input features used and the output features. You can see that, and you can see about the flatten. As I mentioned, you can see that all the inputs were used. You can see this, and the spectral features. These are the parameters values I've used, and you can see the spectral power and the after filter, all this one, and the same for the raw data. So raw data used for the temperature, and let's go to the neural network classifier. So I trained with the sequence of dense layers, 100 neurons, 50 neurons, and 20 neurons, and then the learning rate as mentioned as 0.0005. So get I trained with a different approach, and then I got this as a more accurate. And then you can see the accuracy here, the direct sunlight, and you can see I tested with some data, and with my data, the which I've not used for the training, I used that as a testing data, and I've got the accuracy as 94.5. Once everything is done and able to deploy back, so it is a simple like you can go to the deployment, you can just download as a C++ library, or if you want to build it as a specific firmware like Nordic Thingy, you can able to build it and flash it back. So that's all about this one, and the next thing is like so you can able to see all my demonstration here, like with all the detailed info. And the MQTT demo is not able to do it in this first presentation, maybe, but that is a future thing. We can just able to enable that, and then we can able to like because this for the SIM also, so that you can send the result or publish to any server, so that you can monitor that lively, like through remote, like whatever the results the model is generating, like for every cycle. I hope this explains about the detail of my project, and please follow me in my project page, like you can follow in the Hackster, the cold chain monitoring. And my extra profile is just money online. You can search it, and I'm in LinkedIn. The Twitter ID is idea money underscore. Yes, that's all about me. Thank you.
Well, so thank you everyone for joining us today, and a big thank you to all of our community spotlights for sharing their projects. I'm super excited to see what everyone builds next. So looking ahead, we do have, you can check out our website for some upcoming partner webinars, and those are totally free. You just have to register. You can also, on our Impact Spotlights page, you can go ahead and sign up and receive emails so you always know when Impact Spotlights are coming up. As well, I'm excited. Our next Impact Spotlights will be on February 27th, focused on fitness technology. So if you happen to have a project that focuses on fitness tech and you are interested in being one of our community spotlights during Impact Spotlights, you can reach out to impact@hackster.io. So thank you again, everyone, for joining us today, and a big thank you to all of our community spotlights for sharing their projects.